Okay, we are wrapping up section 2.2. Today our topic is zeros and writing polynomials. So kind of working our way backwards. Yesterday when we were graphing them, they gave us the polynomial or the factors. We found the zeros and we graphed it. Well, today we're going to be given the zeros and we have to go find the polynomial that it came from. So being able to kind of go both directions with this. The first set of directions that you are going to see up here is the set of directions that we are going to use for the first, I think, 4 questions today. So if you want to write it down one time, we are going to see 2 different types of directions. This is one of them. There's some very important things that we are going to point out in these directions as we look at this. So looking through this, the first thing that I would point out as we look at our directions is the first question. Find a polynomial. One of the keys that I'm going to stress as we head towards our quiz and our test, because remember that this is one of our more challenging ones, is answering in the correct format. When the question is find a polynomial, we will need to at some point FOIL to get our answer. Okay, so we're going to have to do some multiplying to get our answer. And remember, a polynomial is something that looks like x squared plus 5x plus 7. Okay, no parentheses, no nothing. It's just terms added together. So that's part of it, is recognizing the fact that our answer is going to look like a polynomial. Second, it says that it's going to have a degree of n. When we are done, our answer's biggest exponent, that's what degree means, right? Our biggest exponent will match whatever they tell me n is going to be. Okay, and that's kind of the trick to this first section, is getting it to match that. And then it says that we can only use the zeros that they give us. So I don't get to expand the list. I can only use the zeros they gave us. And the last part is this. There's more than one answer possible. And we'll talk about that at the back end of this question, is why do they have to tack that on there? Why is there more than one possible answer? All right. So they tell us that it has zeros of -2 and of 3. And we're going to write a polynomial that has a degree of 3. All right, so this first part I'm going to do one time, really, and this is the last time I'm going to do this. They're giving us the end of our problem yesterday, and they're saying that at the end of this, we found out that x equals -2. Where did that come from in my parentheses? Well, if you remember what this was, we solved for x. So if I move this back over, like unsolved for x, I would move that back over and it would look like x plus 2 equals 0. And we set it equal to 0 because it was up here in a parentheses, right? Remember where all that came from? Okay. So now look at the number they gave us as a 0 and what it looks like in my parentheses, and give me a non-mathematical way of saying, okay, if they tell me this, how I can write that. Opposite sign. Okay. It is as simple as that. When they tell you the 0, which is this list, these are called zeros. When they tell me the 0, this list is called factors, will be the opposite sign. Okay? So if they tell us that the 0 is 3, the factor looks like x minus 3. Good so far? Okay, well, they tell us it has to have a degree of 3. If I were to FOIL that, I would have a degree of 2. 2, right? FOIL that, we get an x squared. So it doesn't currently have a degree of 3. Now, there are 3 different ways that we could fix that issue. Yes, we need to come up with all 3 of them, and I'm going to tell you why 2 out of the 3 of those won't actually work with all of our directions. Okay? So 2 of them I want you to come up with that aren't actually going to work. And I heard one of the options here. You said throw an x in front of it. Okay, so if we throw an x in front of it, let me make some room here. Perfect. Does that fix the fact that our degree wasn't 3? It's now a 3, right? X to the first, x to the first, x to the first. Degree of 3. Why does that not work? It adds another 0, and they said we could only use the list they gave us. This adds what to our list? 0. Okay, so yes, that was one of the 3 things that I wanted us to come up with. Doesn't actually work because it added a 0. Okay, now let's come up with a second option. Add an x squared. Okay, so if I put a squared in here, is that what I mean? Okay, perfect. Does that fix our degree? Now it's a degree of 3, isn't it? Does that work with our directions? No, because now 2's not actually a 0, is it? If I set that equal to 0, and I go to solve it, we're running into an issue, aren't we? Yes, there it is. Okay, so you guys are doing a great job picking out my 2 out of the 3, and I just heard the third one. Put the 2 outside, make it a multiplicity, right? Use that multiplicity thing we just learned from yesterday. Now, does it matter which one I put it outside of? No, that's the last part. More than one answer is possible. You get to pick, okay? Pick one of them. It doesn't matter. But now, is my degree 3? Yes. X squared is going to come from this guy, x to the first here. That's an x to the third, okay? I still have the same zeros that I had up here. This one has a multiplicity of 2, and that's fine. That's exactly what we needed to use, actually, is the whole idea of multiplicities to get to the correct degree. Okay, now let's go back to what the question was. Have we answered the question? No, because the question was find the polynomial, and we currently have them listed as factors. So we haven't FOILed yet. That's the last process in all of this, is that I need to write this twice, FOIL and FOIL. When you do this, just do one pair at a time. So pick one pair. It doesn't matter which pair. Pick a pair and FOIL. Okay, I picked the first two, x plus 2, which will give me x squared plus 4x plus 4. Remember when you do this, that you then have to FOIL. I use the word FOIL. Distribute it through the second one. Be careful. This is where mistakes happen. One term at a time. Take my x squared and distribute it through to both terms. X cubed minus 3x squared. Take the 4x, distribute it through to both terms. Plus 4x squared minus 12x. Take the 4, distribute it through to both terms. Plus 4x minus 12. So do you see how from this line to our answer, which we have one more step, there's a good chance of making little mistakes? Just take your time. Double check your work. But combine your like terms. That's our last step here. And my like terms, let's see, I've got an x cubed. I've got 2x squareds. When I put those together, I get positive 1x squared. A negative 12 and a positive 4 would give me a negative 8x minus 12. That's one correct answer. You could have instead, remember the more than one possible, we could have as a second option squared this parentheses, wrote that twice and FOILed. We would get a slightly different answer. Both would be correct. There is not a better option. It's totally whichever one you pick to choose, put the 2 on, and that's up to you. Questions on that? All right. So we're going to see a couple of varieties of this. I think we kind of actually know the little trick to this one. But same directions. Like I said, we're going to use the same directions on this. Sailor?
Sorry,
That's okay.
would have been n equals 4.
Uh-huh.
We had put a 3 instead of 2.
You could have. Or you could have put them as both 2s, like a 2 and a 2. Yeah, or a 3 and a 1, as long as it adds up to 4. Absolutely. Absolutely. Okay, so the two things I want to talk about on this one. I think we already kind of addressed the whole 0 being in that list. If 0 is in our list of zeros, it's an x, right? So that doesn't look like a parentheses. That looks like just a plain old x. These look like what we just talked about, right? So if it's a negative 1, we said non-mathematically we're just going to use the opposite sign, right? X plus 1. And then if it's a positive 4, x minus 4. Currently a degree of 1, 2, 3, and I need it to be a degree of 4. And I want to be super lazy about it. You got options. X squared on the outside means I don't have to write anything twice in FOIL, does it? If you ever have that option, you have a plain old x in your polynomial or in your factors, this guy, you got a 0 of 0, that's where I can adjust all of it, because then I don't have to write it twice in FOIL or anything like that. I currently have a degree of 3, I need it to be 4, so I need to make one of them a little bit higher, 2, right? Let's say I needed that to be like a degree of 8, and I currently had it as 3, I can make that a 5. right? I can put all of it on that x and have way less work to do. So you absolutely are welcome to take the lazy, I encourage you to take the lazy options when we get them, all right? So when you do this, so again, we're looking at factors right now, and the question was polynomial. Do the FOIL part first. Always save your distributing for last. That's where people make the mistake. So do your FOIL part first, and then we'll distribute that x squared through my answer. So when I FOIL this, I get x squared, let's see, negative 4 plus 1 would be negative 3x minus 4. Distribute that x squared through. X to the fourth minus 3x cubed minus 4x squared. All right, how we doing? Good? Ready for your next variety? Our next variety, same question at the top, different type of set of zeros, okay? I want a degree of 6, which means my biggest exponent is going to be a 6 when we're all said and done, right? But I don't want any real zeros. In our warm-up, we ran into something that didn't have a real zero. Think about the situation where we've stopped and said, okay, we're not getting any real zeros from this. Yeah, and you're actually a step ahead of me. What is it? What process are we doing at that moment when we say, oh, this isn't real? Square rooting a negative. Okay, so you already got it, but I'm going to work our way backwards from this. To square root something, I would have been looking at this, right? And I would have square rooted a negative. So back up a step here. If I was at x squared equals negative 1, bring that back onto the same side, I'd be looking at a something squared, right, plus a number. Absolutely. Now, that factor right now is an x squared plus a number, and I need it to be an x to the 6th when I'm all said and done. How do I fix that?
X to the 6th.
Aha, there's my two answers. Put it as a third, which means I have to write it 3 times in FOIL and FOIL, or x to the 6th. Isn't that still an even, right? Can I do that? If I were to set that equal to 0 and solve, wouldn't I be even rooting a negative? And isn't even rooting a negative illegal? Not real? No, any number. I picked one. It's pick your favorite number. Yes, you like 3. There you go. Yeah, no, there is no reason behind the 1. I just wrote 1 up there. So let's talk about generic format here for no real zeros. If I want it to not be a real zero, my exponent needs to be an even number. I need it to be a plus, and then you pick your favorite number. It doesn't matter what number you add to it, but these are the keys: even and plus. As long as it's an even exponent with a plus, it's going to give us an imaginary. Yes. Say that x to the 3rd plus 4 and x to the 3rd plus 2. Yes. Yes, you could. Yes.
So if that was like n to the 5th,
yeah, so let's talk about this real quick. What if they had said n equal, you're saying if they said n equals 5. Yeah, so I keep getting this question. What if they changed that to an odd number? What if the degree they were asking me about was an odd number? Well, guys, it won't. It can't happen. Think about end behavior. If I have an even positive moved up 1, my ends of my graph are both going to head up. A 0 means when it's going to hit my x-axis. And I don't hit my x-axis because the ends are headed the same way, both up. It's moved above my x-axis. It'll never hit my x-axis. That's why there's no real zeros. But if I change my degree to something odd, my ends go opposite ways. It has to hit your x-axis. So that would never be a question. They can't say that it's an odd degree with no real zeros, because if it's an odd degree, at some point it has to hit your x-axis because the ends of your graph go opposite directions. At some point it's going to cross over your x-axis. So it'll always be even if we have no real zeros. Questions? All right. Changing the directions. I told you we had 2 types of directions today. Here's the slight, they look super similar. The slight change. It no longer says n equals at the end of our problem because they're saying of any degree. Don't make it any bigger than it is. Okay, just use the zeros they're asking you to use. Don't like square anything or cube anything because that's just more work for you. It does still put that little caveat at the end that there is more than one answer possible if you were to decide to like square something. Why? Don't do it. Okay. The other thing I wanted to put this example up here is how do we deal then with fractions? How do I get a fraction into a factor? Now, you are not allowed to write x minus a half. You cannot have a fraction in a parentheses. And my slide and dividers, I'm still talking to you, you still can't leave a fraction in a factor, okay? So how are we going to get there? We're going to work our way backwards. At the end of this problem, x equal to half, right? And if I were to unsolve for x, the last thing we would have done is divided by 2. So slide that 2 back out of there, right? And then we would have brought that 1 back to this side. My factor would have been 2x minus 1. Now, I don't want to go through that process every time. So let's take a good note for ourselves here about when I look at a fraction, which number goes where in my factor. Where does our denominator go? In front of the x. The mathematical word for that is the coefficient. You don't need to write the mathematical word. You can write in front of the x for yourself. Okay? Where does the numerator go? It's added or subtracted, right? Opposite of whatever sign it is. So whatever sign it is, like that's a positive fraction, I would subtract it. If it was a negative fraction, I would add it, just like we saw before. So opposite of what we see. Maybe we put that as our little note here. Add or subtract opposite of whatever it currently is, right? So we know that this one turns out to be 2x minus 1. You guys try to write the 3/4 in there following that little rule there. Put the 3 and the 4 in the correct place in your factors there. Okay, we know our denominator is going to become the coefficient of x. Our numerator is what we are going to add or subtract opposite of the sign that we see. So you should have correctly written this as 4x positive, so minus 3. Same thing with these zeros here, opposite sign, so x minus 2 and x plus 3. We have 4 parentheses up there. I will tell you algebraically the mistake that people make is going to happen on this one. The first step we usually do pretty good with. We FOIL, do 2 of them at a time. So you can do these 2 and these 2 in the same step. It's the next step that people make mistakes with. When I FOIL this, I'm going to get this polynomial here. It is still squished up next to this, so I then will need to FOIL a second time with the answer that I get for the second 2. Okay, so let's go ahead and show that. When I FOIL here, I get 8x squared, 2 times negative 3, negative 6, minus 4, negative 10x, plus 3. In the second 2, I get x squared, positive 3, negative 2 would be a positive 1x, minus 6. The mistake that I will see is that then people try to just combine like terms at this point, but we have to FOIL one more time. You're not going to do a lot of these, okay? So don't get too excited. I know that it's a lot of work. I get it. But you're not going to do a lot. So now we are going to carefully take each term and distribute it through each of those until I get through all 3 of these. So 8x squared times x squared would be 8x to the 4th, times x would be 8x cubed, times negative 6, negative 48x squared. And then I take the negative 10x and I distribute it carefully through all 3 of those. Negative 10x cubed minus 10x squared plus 60x. And then I take the 3 and carefully distribute it through all of those. Plus 3x squared plus 3x minus 18. And I know that's a lot of terms up there. Can you see how easy it is to make a mistake? Write a positive instead of a negative, forget a squared, anything. There's just so many symbols and numbers. Just be cautious, double check your work, okay? Combine my like terms and we are done. we have 1x to the fourth, and 8x to the fourth, I should say. 8x cubed minus 10x cubed is negative 2x cubed. We have a couple x squareds here, so negative 48, negative 10, negative 58, plus 3 would be negative 55. X squared, what are we on? Plain x's, 60 and 3, 63, x minus 18. All right. We are about done today. I just want to stress again, I know I've mentioned that this chapter is hard, so just a reminder, when we are looking at this, you need to understand what is being asked of you and what we are looking at. When you are looking at a list of numbers, those are the zeros of the function. When you are looking at the parentheses, those are the factors of the function. And when you are looking at it all multiplied out with individual terms, that is the polynomial. Make sure you answer the question in the correct format. Can you see how if you stopped at the factors because you thought that's what you were supposed to do, but the question asked you for the polynomial, how you're going to be missing quite a few points because that's a lot of work. Don't stop at the wrong format and miss out on all those points just because you didn't pay attention to the question, okay? The last thing is I'm going to let you take a second and talk at your table. Look at those four and identify as even, odd, positive, or negative. Make sure you guys all agree.
Wait, so which one's that?
Yeah, that one is negative and because it's opposite of
All right, let's go ahead and get our answers up here. I'm going to kind of pick one from each table to see how our conversations went.
Pretty good.
Starting with, pretty good? You got the first one? Positive, even, okay.
You would have gotten that wrong.
Jonathan? Good. Sailor, how about the next one? Just picking somebody from each table. Okay. Alex? Even, negative. All right. How'd they do?
Good.
The people I picked? Okay. Even and positive, negative is easy to pick out. If you're going to spend any time looking, it's going to be at the odds, right? Paying attention to which one's positive and which one's negative. Decreasing, increasing. You guys have a worksheet tonight and a bit of work time. We're going to use it.